The ocean is boiling. Not literally, but the numbers coming out of the world's top climate agencies right now are so alarming that scientists are struggling to find the right words to describe what is happening beneath the surface of the Pacific Ocean. In 2026, a force of nature is waking up, one that has the power to flood entire coastlines, burn continents dry, collapse food supplies, and push global temperatures into uncharted territory. It is called a Super El Niño, and every major climate model on the planet is now pointing at the same conclusion. This is not a drill. This is not fear-mongering. This is the most significant climate signal on Earth right now, and if you do not understand what is coming, you are going to be completely blindsided by the weather events about to reshape the world in 2026 and beyond. Before we get into what this means for every region of the planet, you need to understand what we are actually dealing with. El Niño is a natural climate cycle that originates in the tropical Pacific Ocean. Under normal conditions, strong trade winds blow westward across the equator, pushing warm surface water toward Asia and Australia. That process pulls cold, nutrient-rich water up from the deep ocean along the coast of South America, which is a process known as upwelling. This cycle keeps global weather patterns relatively stable and predictable. But every 2 to 7 years, something breaks. The trade winds weaken. The warm water that should be piling up in the west sloshes back eastward toward the Americas. Sea surface temperatures in the central and eastern Pacific climb well above their long-term averages. The entire atmospheric engine that controls rainfall, temperature, and storm patterns across the globe gets rewired. That is El Niño. A normal El Niño is already powerful enough to alter monsoon seasons, trigger droughts in Australia, flood the Horn of Africa, and nudge global average temperatures upward. But a Super El Niño is a completely different beast. The technical definition requires sea surface temperature anomalies in the Niño 3.4 region, a specific stretch of the tropical Pacific, to exceed 2 degrees Celsius above the long-term average. That threshold sounds modest. The atmospheric consequences become enormous. The stored heat energy released from the ocean into droughts become multi-year famines. Heat waves become deadly in places that have never experienced extreme heat before. This is the scale of what is now forming in 2026. The last time humanity dealt with a true Super El Niño was in 2015 and 2016. A sudden and persistent change in an entire regional climate system that did not simply reset when El Niño ended. The Gulf of Mexico reached a new baseline level of warmth after that event, and researchers believe it contributed to the intensification of Atlantic hurricanes in the years that followed. That is how deeply a Super El Niño can reshape the climate system, not just during the event itself, but for years afterward. Now the same alarm bells are ringing again, and they are ringing louder. The World Meteorological Organization, which is the United Nations body responsible for coordinating global climate monitoring, issued a major update confirming that sea surface temperatures in the equatorial Pacific are rising rapidly. With further intensification in the months that follow. Climate models from NOAA, the European Centre for Medium-Range Weather Forecasts, the UK Met Office, and multiple other leading institutions are now strongly aligned. They are not just predicting an El Niño, they are predicting an event powerful enough to potentially cross the Super El Niño threshold by the second half of 2026. NOAA's Climate Prediction Center placed the probability of El Niño emerging between June and August 2026 at 62%, with the event expected to persist through at least the end of the year. What makes the 2026 event particularly alarming is not just its projected strength, it is the context in which it is forming. The planet is already running hot. The first 3 months of 2026 were the 4th warmest first quarter on record globally. January through March of 2026 was also the driest on record across much of the United States. The ocean is already holding an enormous amount of excess heat from decades of climate change caused by greenhouse gas emissions. The resulting temperature spike becomes something that has no historical precedent. Carbon Brief, which synthesizes data from 5 major global temperature research groups, predicted that 2026 is likely to become the second warmest year on record. with a 19% chance of surpassing 2024 as the outright hottest year ever measured. There is also a remarkable physical driver behind this particular event that scientists are watching extremely closely. A massive oceanic Kelvin wave is currently moving through the Pacific. A Kelvin wave is essentially a pulse of warm water that travels just below the ocean surface from west to east across the equatorial Pacific. When a large Kelvin wave reaches the eastern Pacific and rises to the surface, it dramatically accelerates El Niño development. The wave currently moving through the Pacific in 2026 is significant in size and strength. Additionally, scientists flagged an unusual set of atmospheric events in April 2026 that could be accelerating the development. A rare occurrence of triple simultaneous tropical cyclones in the western Pacific pushed large amounts of warm water eastward across the Pacific into the very zone where El Niño conditions are monitored. When cyclone activity forcefully moves warm water in the right direction at the right time, it can act like a turbocharger for El Niño development. The combination of the existing Kelvin wave, record-high subsurface ocean heat content, weakening trade winds, and this unusual cyclone activity has created a confluence of conditions that forecasters say mirrors the early development stages of the most powerful El Niño events in the historical record. Now, let us talk about what all of this actually means for the world, because the consequences of a Super El Niño in 2026 are not abstract climate statistics. They translate directly into floods that kill people, droughts that destroy harvests, heat waves that overwhelm hospitals, and food price spikes that push millions deeper into hunger. Understanding the regional picture is essential, starting with Asia, which is home to more than half the human population on Earth. India faces one of the most serious threats. During El Niño years, the Indian monsoon, which delivers the rainfall that the country's agriculture and hundreds of millions of people depend on, tends to weaken significantly. The WMO has directly confirmed that El Niño is typically associated with drought conditions across parts of southern Asia. A below-average monsoon in India in 2026 would devastate crop production across the subcontinent, contributing to food insecurity that could affect hundreds of millions of people. Japan and China's meteorological agencies have both flagged significant weather disruptions ahead. Southeast Asia, including the Philippines, Indonesia, Thailand, and Vietnam, faces the prospect of severe drought during the critical June through September growing season. Indonesia and the Philippines in particular have historically suffered devastating crop losses and catastrophic wildfires during Super El Niño events, as rainfall drops sharply and heat builds across the region. Australia is another country where the word El Niño triggers immediate alarm. The continent is prone to some of the world's most extreme drought and wildfire conditions during El Niño years, and a Super El Niño amplifies those risks dramatically. During the 2015-2016 event, parts of Australia experienced record heat, severe water shortages, and widespread agricultural losses. In 2026, the WMO has explicitly listed Australia as one of the regions expected to face drought conditions as El Niño develops. For a country still dealing with the long-term ecological aftermath of the catastrophic 2019-2020 Black Summer wildfires and ongoing water security, pressures, another major El Niño hits at a particularly vulnerable moment. In Africa, the picture is deeply uneven and highly dangerous. East Africa and the Horn of Africa region, including Ethiopia, Kenya, Somalia, and surrounding countries, historically receives above-average rainfall during El Niño events. On the surface, that sounds like a benefit. But the rainfall does not arrive gently. It comes in violent, concentrated bursts that cause flash flooding, destroy crops in the field, wash away infrastructure, contaminate water supplies, and drive mass displacement. The European Union flagged in April 2026 that El Niño poses a significant risk to the main agricultural season in northwestern Ethiopia, South Sudan, and Sudan specifically through drier conditions that will stress food production in areas that are already experiencing fragile food security situations. Meanwhile, southern Africa faces the opposite problem. Countries like Zambia, Zimbabwe, Mozambique, and South Africa are expected to experience below-average rainfall and drought conditions. During the 2015-2016 Super El Niño, Kenya actually saw a 17% increase in maize production from heavy rains, while simultaneously Southern Africa experienced drought that decimated harvests across the region. That paradox of flood and drought playing out simultaneously across the same continent illustrates how brutally complex and unequal the impacts of El Niño can be. Moving to the Americas, the impacts split sharply depending on location. In South America, the Pacific coastal nations of Peru and Ecuador face extreme flood risk. During strong El Niño events, ocean warming along the South American coast disrupts the cold Humboldt Current, collapses the fishery that millions of coastal communities depend on for food and income, and brings catastrophic rainfall to coastal lowlands. The northern regions of South America, including parts of the Amazon basin in Brazil, face the opposite problem: severe drought that threatens one of the most ecologically critical biomes on the planet. Meanwhile, the southern cones of South America, including Argentina and southern Brazil, typically sees above-average rainfall that can also translate into destructive flooding. For the United States, El Niño brings a complicated and regionally mixed forecast. The Pacific jet stream shifts southward during El Niño, pushing more storm systems into California and the southwestern states during winter and early spring. That can provide drought relief after years of water deficits. However, the southern plains of the United States, including Texas, Oklahoma, and Kansas, remain in a historically severe drought going into 2026. NOAA analysts who studied the situation carefully noted that even a strong El Niño would bring significant rainfall improvement to the southern plains region, but that given the extreme depth of the drought, with reservoirs, streamflows, and aquifers all critically depleted after nearly 6 consecutive drought years, it would take more than one wet season to meaningfully recover. And if the rainfall arrives too quickly in concentrated events, rather than gradual soaking rains, it simply runs off as flood, rather than recharging the underground water reserves the region desperately needs. For the Atlantic hurricane season, El Niño historically acts as a suppressor by increasing wind shear over the Atlantic basin that disrupts hurricane formation. This could mean a below-average Atlantic hurricane season in 2026, which would offer some relief for the Gulf and East Coast. However, the Pacific sees the opposite effect, with increased cyclone activity threatening Hawaii, Guam, Japan, and Eastern Asia. Europe is entering this El Niño period under the pressure of already record-breaking warmth. The WMO confirmed that the May through July 2026 temperature forecast shows above-normal conditions across Europe and northern Africa, with a particularly strong signal. Central Asia is another region expected to receive above-average rainfall during El Niño, which brings flood and landslide risks that can devastate mountain communities and destroy agricultural land and irrigation infrastructure. Beyond the immediate weather disruptions, the economic consequences of a Super El Niño forming in 2026 could be staggering. The food system is perhaps the most exposed sector. El Niño is notorious for sending commodity prices into sharp volatility. During the 2023-2024 El Niño event, which was a strong but not quite Super El Niño, global rice prices hit 15-year highs as India restricted exports to protect domestic supplies following erratic monsoon conditions. In 2026, with India, Australia, Indonesia, and large parts of Africa simultaneously under stress, the risk of multiple major food exporters reducing or restricting exports at the same time is very real. The commodities most directly threatened include rice, sugar, cocoa, coffee, wheat from affected growing regions, and palm oil from Southeast Asia. A simultaneous supply shock across multiple staple crops would send grocery prices sharply higher globally, hitting the world's poorest populations hardest at a moment when many are already struggling with elevated inflation from recent years. The health consequences of a Super El Niño are also serious and often underestimated. Heat extremes increase mortality directly, particularly among elderly populations and people in regions without access to air conditioning. Flooding creates ideal conditions for the spread of waterborne diseases, including cholera, typhoid, and hepatitis A. Drought and food insecurity increase malnutrition rates, particularly among children under 5 years old, weakening immune systems and making populations more vulnerable to infectious disease outbreaks. In East Africa, El Niño's heavy rainfall has historically been associated with increased malaria transmission, as standing water creates mosquito breeding grounds. The UN and major humanitarian organizations have already begun contingency planning for what could become a significant global humanitarian response if the 2026 El Niño develops at the strength that current models are projecting. There's one more dimension of this story that deserves serious attention, and it is one that fundamentally changes how we should think about El Niño in the modern era. In the past, El Niño was understood primarily as a natural climate cycle, powerful, disruptive, but ultimately bounded by natural limits. That understanding is no longer fully adequate. Human-caused climate change is not increasing the frequency of El Niño events, but it is amplifying their impacts. The reason is straightforward. A warmer ocean holds more energy. A warmer atmosphere can hold more moisture. When El Niño releases that ocean heat into the atmosphere, it is releasing heat into a system that is already warmer than it has ever been in human history. The result is that the same El Niño dynamics that produced one level of impact in 1982 or even 1997 now produce more intense heat waves, more extreme rainfall events, and more severe droughts because the baseline conditions have shifted. Scientists confirmed this explicitly. While climate change does not make El Niño happen more often, it amplifies the associated impacts because a warmer ocean and atmosphere increases the availability of energy and moisture for extreme weather events. The 2026 Super El Niño is arriving not into the climate of the 20th century, but into the climate of the mid-21st century transition period, where every degree of warming acts as an accelerant on every extreme event. This has profound implications for the 1.5 degrees Celsius warming threshold that was established by the Paris Agreement as the critical guardrail for limiting the worst climate consequences. Scientists have noted that the 2026 El Niño will likely complicate international efforts to stay within that target. During El Niño peaks, temporary spikes in global average temperature can push the measured annual average above 1.5 degrees Celsius, even if the long-term trend has not yet permanently crossed that line. The symbolic and scientific significance of breaching that threshold, even temporarily, would be enormous, signaling that the climate is approaching a genuinely dangerous new regime. What should people, governments, and communities actually do with this information? The good news about El Niño, relative to other climate threats, is that it can be forecast with meaningful lead time. Unlike a sudden earthquake or an unpredictable tornado outbreak, El Niño develops slowly over months, and the climate science community has become increasingly skilled at predicting its onset and tracking its intensification. That lead time is valuable. Farmers in drought-prone regions can shift to more drought-resistant crop varieties. Water utilities can begin conservation protocols and storage programs before reservoirs drop critically. Governments can pre-position food aid in regions likely to face acute food insecurity. Disaster risk agencies can train emergency responders and pre-stage equipment in areas most likely to face flooding. The FAO has explicitly noted that because El Niño can be predicted months in advance and develops with a relatively regular pattern, it is possible to design anticipatory actions and prepare emergency responses well ahead of time, and that proactive preparation consistently produces far better outcomes than reactive emergency response after the disaster has already arrived. The challenge is translating that scientific forewarning into actual action at scale. Historically, there's been a consistent gap between what climate scientists know months in advance and what governments and communities actually do with that knowledge. The 2026 Super El Niño is arriving with more advance warning than almost any previous event of its magnitude. The question is not whether it is coming. The question is whether the institutions and communities most at risk are using this window of time to prepare. The Pacific Ocean does not care about political schedules, economic forecasts, or geopolitical tensions. It operates on its own timeline and by its own physical rules, and right now, those physical rules are pointing toward one of the most significant climate disruptions of the 21st century forming over the coming months. Every credible climate monitoring system on the planet is sending the same signal. The subsurface heat content is building, the Kelvin wave is moving, the trade winds are weakening, the sea surface temperatures are rising. The Super El Niño of 2026 is not a possibility that scientists are nervously hedging around anymore. It is increasingly the most likely scenario for the second half of this year, and its fingerprints will be felt on global weather, food systems, and human lives for years to come. The time to understand what is happening is right now, before the impacts arrive. Because once El Niño is fully established, you do not wait for it to pass. You survive it. And how well any region survives it depends almost entirely on how seriously the warning was taken before it arrived.